So welcome everyone for the first lecture over the radar data processing in the SNAP. So today we are basically going to show you how basically process the GRD data product. Okay, so GRD data product is a very useful product which you can access directly inside SNAP. Okay, so let's start with the data, how we are going to open it and how we're going to process this data sets. Okay, so basically I'm just trying to open the data where I have my data sets. So here is my data. Okay, so let's try to export this this is cyclone, the Asani, which is happened in to Andhra Uppal. So we will try to focus over that particular place. Okay, so this is the data. When you just simply open it here, so you just see here, you will get the metadata information. So over the metadata you will get the information about the exact date when this data is actually collected. It's a 10th May data, as you know that that Amphan cyclone is hit in obviously that is I think 9th May sometime it was hit at, or 9th to 10th May it is actually landfall. So during that period only I am just trying to download these data sets. Okay, so this is the information about Sentinel-1A. So the product type will be the GRD. Okay, so I'm using the interferometric wide mode, so all the data informations you will get from this particular place. Okay, so now suppose you want to see the data type, so you can go and expand this BAM. Okay, so then simply click on this amplitude VH, so you can able to see the data quality of VH. So let's focus over that particular area, how it is looking in VH and how it is looking in VV. So you will get all these two types of data if you want. Okay, to see. So see, this is the data which I'm trying to focus. Okay, so this is over the VH and this is over the VV. So usually if you compare VV and VH, then obviously you will see the VV is actually good to identify the area of the flood. Okay, so like wherever there is water body over the land, so you can very easily identify. And VH is very good to differentiate the area of agricultural land and the forest area. So those kind of differentiations you can identify very nicely over the VH. Just see here the difference, you can understand better than this. Okay, so let's see some other processing techniques, so how we will going to implement this data in a very nice way. So this is the in general which I just showed you, suppose. Okay, and you can process many other data sets over here also. So here basically I will try to show you how to export this data, and after exporting how we will going to do the filtering over these data sets, and finally we will going to do the geometry correction of data. So before that we will do some subset of this particular image where means I want to process this all the process. So for this, suppose I will make a little bit of focus over this much area. Okay, not the full area. So this is the area which I must focus over the full scene. Okay, so now here basically I'm just trying to focus over this particular place only. Okay, so Sentinel-1, we already opened this Sentinel-1 GRT project, which is actually very good product over here. Okay, now because SLC product, which is actually very heavy product, okay, which I found than GRD. Because SLC you will get amplitude and phase both the informations, but in case of this you will get only the amplitude informations for the, and this is will be the multi-looked data directly process it will happen. Okay, and that is the advantage you can say over the GRD data. Okay, so here you can zoom in and zoom out and you can see the particular area which you want. Okay, so now whatever we are actually focused, the area I actually focused. Okay, so that area I must want to subset. It is not taking the full large area, so better I will focus over some particular area where this is a zoomed, whatever the area I just zoomed na, so I just want to that much area to be subset. Okay, so for that only I am just going to focus over the subset. You can see here raster, and we can go for the subset. Okay, so here you just see automatically the blue rectangle, it will taking the subset area. Okay, so if you know the precise geographic coordinate, then you can go and put the boundaries coordinate. Okay, you can give the coordinate over here also, and you can subset. Okay, now you can click on OK, and you will get your subset image. You just see here. So if you just open it, okay, so if you want to save it, so then go to the file and save the project wherever you want to save. But I am not saving it now. Okay, I am just want to see the data. Okay, last final product I will going to save. So this saving is same. So you just select this product and you can click on save. So it will take places of my system, so already my system was less out of space, so that's why I'm not saving it anyway. So you just see here after the subsetting, so whatever the area you just focus on, so now it will come only that much area only, so it is not taking the large area. So you just simply see for the VAB also, so then also you can able to see the difference. This is actually our Andhra Upakul. Okay, so this is our Andhra Upakul where I actually trying to show this two man. This is two separate views I just want to show. So if you want to see windows and tile evently, okay, so now you can go and the tools or you can open the view. The navigation tools is required now, so you somewhere you have the navigation tools. You just see here where you get the tools. Okay, so windows, so many data actually it should show in a navigation tool. So this is the navigation tools. Okay, so you just able to see this is a navigation tools. So now if you want to collect it, so now you just see here, if I focused over one place, you can able to compare these two formations. So now you see the VV and VH, how the differences is coming. Okay, so informations are much more clear over here. So if there is water, because after this you can say that rainfall due to this ascending, so there is definitely there is with the water. So, okay, so that water will be stacked here, so that's why it is coming very much focused over here in the VV. Okay, so that is the way you can identify this type of area. So now whatever I did, actually this is still not done any kind of filtering over it. So now if I want to do any kind of the filtering, so before filtering, what you have to do, you have to do the calibration. Okay, so calibration is a very good process that it will creating your images in a multi-look data. Okay, so I already explain it in the SARscape. That is, I found is much more easier technique than this. But anyway, so anyway, you can go to this radar. Okay, so radiometric and then calibrated. Okay, so this is the calibration. So now here, which data sets you have to give input? Obviously your subset data. See, automatically it is taking that particular data sets only, and the pre-processing, it is taking over the both PV and VH image. So what you have to understand, that is this is a calibration informations, okay, over your subsetted image. So what I won't want I can remove this all the name, so that it will be by easily we can understand what is this output will be. Okay, so I am just specifying this particular output which I am going to calibrate it, where I am saving, so I can save it in that particular folder. Okay, so like you can go to this D drive. Okay, and I have my E drive, and I can go to my the folder which I just created for you, radar data. Okay, so there Asani. Okay, so there I can view, refresh a new folder. I can create outputs I can make, and under this I am just trying to save all this data. Okay, so as outputs, now you can run the data output, so you will see the calibrated information. So it's a new things will come, so that will come as a underscore cal. So this, see, this is the caliber. So how we'll see, so remove this both the image, and now you try to open this one, the bands. So you see here there's a sigma naught value which is coming. Okay, so what is this actually doing? After calibration you will get from the dn value, you will convert it in a sigma naught value. There is a backscattering value which is coming now, so that only I just try to create it. Okay, so this is your VH sigma, and this, so these steps you also, it is helping you to reduce the noises. Okay, it's already, it is reduced the noises from that raw images which you are just using. So after doing this, we will go for the more clear, that is the filtering process. Okay, so speckle filter process, we will, once we will apply over the image, so our image will come with the more detailed information. So we will be more close to go to create this output as a geometry correction process. Okay, so that we will try to focus over here, how we will going to exactly focused over this particular area. Okay, like wherever this Asani cyclone, after cyclone, what are the places which has more water. Okay, so that we will try to focus over this particular information. Okay, so even you just see here, if you want to go for this histogrammic, if you want to manipulate now, so see here it is coming in a single place now. So now you can convert is to histogram to the linear, so you can control the histogram in, because here it is coming in as in a one place. So simply right click, okay, and go to the click on this linear to the dB. You can click on yes. Okay, and you just see here, okay, right click and near to yes, and click as a yes, the virtual band in a dB. So here you will see see, now you see the histograms which you can operate very nicely from here. Okay, so you can operate the histograms very nicely. If you want to stretch it, you can stretch, and you can get the information which was earlier it was difficult means to doing that. So that's why, yeah, you can create the information. I will come out with a very different kind of information, but anyway, now we will go for the speckle filtering now. So obviously we will get better informations than this. Okay, so I will go to the radar. Okay, so speckle filter, and I will go for the single product, the speckle filtering image informations now. So here what should be I give input, my calibration informations. Okay, so that is my input will be there, and after calibration what will be the calibrated speckle filter. So calibrated speckle filter, so here also you will get the name by default. So you have to get an output understanding about your output by the name, the calibrated speckle filter. Okay, so your input should be your calibrated value. So pre-processing you will going to apply over all the 4 bands, so that you are trying to apply over here. Okay, so let's run and see how much this after filtering, how much the output is actually going to come. So it will give you the brief informations about how this data is actually looking like. So let's see, let's wait for a few minutes. So you can compare these two products, like one is speckle filter product, one is non-speckle filter products, before filtering product. So you can compare these two products. Okay, and then you will get an idea very nicely this difference, how much the differences is actually coming. So we'll see this information. Just give me few minutes. Within that this processing will going to finish. Then we can get an idea. Okay, so because filtering is a very important process to removing the noise over the radar image. Okay, and there is a various filtering process which actually I forget to show you. There is you have a lot of options to do a different kind of filtering. Okay, so that process you can apply. Okay, just a minute, we can finish it, then we'll just see. Because after filtering we can move to the terrain correction process, and terrain correction process is the process of your geometry corrections. Okay, so that is the process which we will going to follow. So see here, there is output, this is the differences, processing, and you see here, so this I use actually Lee Sigma, so you can go for the filtering techniques. Okay, so anyway, let's see the results after the outputs came. So I am just expanding this filter one, go for the band, and suppose I am just trying to compare these two now. So one, you open the before classifications, and after you open the after speaker filter. Okay, so you see here, if you want to navigate, then you can go and tile evently you can do. Okay, and navigation tool you can take, and you can now it activate here. Just see here, so before filtering and after filtering. Okay, so how the differences will be, so it's will much more clear to you. Okay, so this is the difference of filter process, before filter process and after filter process. Okay, so this is the 4. So 4.1 is the after filter. You will get see the smoothness over the image, which is earlier it was very rough, so that kind of smoothness you will get over the image after this filter process. Okay, so this is we called as a filter process. So now you want you are already confirmed with the filter process, and now you want to go for the terrain correction process. No? So for this I am going to the radar. Okay, then geometry corrections, terrain corrections. Okay, so here in this case I am going to use the range Doppler terrain correction process. Okay, so in this process is automatically it will download the the DEM SRTM DEM for this. Okay, and then it is automatically rectify your image, and you can take this image in ArcGIS or our ArcGIS Pro, and you can process this data very nicely there. Okay, so that is the advantage. See, suppose if you have your ArcGIS data, and if you don't have data to process in radar set. Okay, so or radar SARscape, if you don't have SARscape to process this images. Okay, so then you can use this our SNAP tool, and this pre-processing steps you can done in this SNAP, and you can take this data in ArcGIS Pro and you can use it. Okay, so that steps I'm going to show you. So now you can see this IO parameters, this is the processing parameters. Okay, you just see here the SRTM DEM only I'm going to use it here. Okay, so you have the list of DEM, so whatever DEM you want you can download accordingly. The same process we are actually doing for in our SARscape, where we are actually using the same procedure to downloading the SRTM DEM to rectify our audio. Okay, and you can fix your projection system also. For this I'm just taking WS984 only. Okay, so now the outputs, so final outputs which we're going to start give, that is the Spark TLC. So that is the output. So simply click on run, and let's see the output, how it is actually come. Sorry. So we will wait for a few minutes and to see the outputs. So it will take few minutes time because it is downloading the DEM, and then after that it is actually the processing it, and then you will get the output which is terrain corrected and geometry corrected data, which you can take it any system, and there you can process it. Okay, so that is the advantage of SNF, you can say. If you don't have SARscape to process your data, so you can use this tool to process any data. So finally you will have these two data sets. Okay, so you can take it, okay, and you can make it and see this is the geometry corrected data. Okay, so if you want to make it as a linear, so you can make it as a linear to dbes, and here also you can make it as a linear to dbes. Just see here, so this is the looking like that. Okay, so that is the way you can convert it. Now the final thing which we're going to do, that is the composite image. So we are actually creating the composite image using the band combinations. Okay, so here in radar we are actually putting a different kind of band combinations to understand the water area. If I want to focus over only the water area, we'll put a combination of the two different band combinations now. So to making the band combinations, composite band, or you can say RGB. Okay, so I am just going to open it here in window. You can go open RGB windows. Okay, so you can use these RGB tools. So sigma VV, it is already selected. Okay, so in that case I am just using sigma VV DB. Okay, so here also I am just sigma VV VH. So here I am just going to do the sigma VV and VH ratio, instead of ratio. I am just want to calculate the differences here. Okay, so how we are going to calculate the differences over this image? So if you go here, okay, so whatever the expressions will be there now, so you can remove these expressions also. Okay, and now you can the ratio means the differences you want to calculate, that is over the VV VH VH minus VV. So one time you have to click, I just click the double times. Okay, so let's click on the VH, okay, minus, okay, VV, just one time. Okay, so this is the only image means the band you have to select, then clicks. Now my expressions is right. Okay, so you have understand how I just created the extraction. So now if you confirm, then simply click on OK to create the composite image, and here you will get the RGB composite. So wherever there is a water area, so you can see all this area which is filled of water now. Okay, so maybe it is after cyclone effect or not, so that we need to check, because as from the image it is showing that this water will be there here. So maybe it is irrigational lands, all this area. Okay, so that is because I'm not getting water area much over here, so maybe it is not that much affected by this Ashani cyclone. Okay, so that we have to check over also, means with the ground truth. But in sense, means my main focus is how we're going to differentiate all this area as a water body now, so that I'm just trying to focus over here. So now if you want to see it in suppose our ArcGIS Earth, so you can simply take it in export Earth in a KMZ, and you can save it this data wherever you want. Okay, suppose I just trying to save this data radar image, Ashani cyclone and outputs, or you can go back and give RGB Andhra area. Okay, so I just give the name as Andhra. That's all. That is just it is directly converted into your image in KNZ. And if you want to trying to open it in ArcGIS or ArcGIS Pro, definitely you can open that, but there is one more process is also there. Okay, so that is basically you can save your map if you want to save it in suppose TIFF or GeoTIFF, whatever the formats you want. So there also you can convert it. Okay, so that is the process also you will be there. Okay, so that's all. Okay, so finally, if you want to transfer this file into a TIFF file and you want to try to process it in our ArcGIS and ArcGIS Pro, so that you can do that. So here you can go in export, okay, and you can save this data in a GeoTIFF. So wherever your output files will be there, okay, so the final output file, the subset TIFF, okay, the GeoTIFF format, you can just simply click on export data. That's all. So it will be converted in our that file. Okay, so that's all from my side, but if you want to see, so you will see that also, right? Okay, just wait. Okay, so that's from my side. So I hope you like the session. So I already told you the process, how we will going to export the data in a GeoTIFF or NB, whatever the formats you want. Okay, so after that you can take it in your software and you can do all the processing techniques whatever you want. Okay, so that's from my side. Okay, thank you.